Welcome all. This is a very important class. We'll discuss about the errors, type 1 and type 2 errors, and then the power of a test. You are testing mu 20 against mu 30. That means the alternative of mu 20 is mu 30 only. There are only two chances. Suppose you are not in school, that means you are in house. You are not on road, that way. You have only two alternatives. It's fixed. Either mu is 20 or mu is equal to 30. Suppose you don't want to accept the fact that mu is 20, then you should take mu 30. And the observation, the sample, you can say single sample, a single observation is there. On that basis, you need to find the errors, probability of making a type 1 error. That is alpha, level of significance we say, probability of making a type 1 error. So this person, level of significance, you know, this part here, we say this is our LS line, level of significance, okay, and the probability of that we say error, the right hand side, okay. So what is type 1 error? This is the error, this is the area, okay. This is the probability of type 1 error. So if you find probability, that will be area, maybe 5%, 2%, 3%, whatever. The blue area you see to the right of this line is the line of the level of significance, we say LS. Right to the line, the blue area you see, that area is the probability of making a type 1 error. Why we say that this is the error? By central limit theorem, we know that this one is normal, x bar minus mu divided by sigma upon root n. That should follow a normal distribution. We take test statistic. In the easiest case, I am saying x bar minus mu upon sigma upon root n. We set mu, and from the sample, this is our population, and we take our sample, and from the sample we find x bar. Suppose we know sigma as well, so we know sigma, we know the sample length, whatever it is, we know x bar. If you put everything here, mu is the unknown, and we want to say something about mu, okay. We want to say something about mu, that is the unknown, and we should know sigma like 20, 10, whatever. We know n, suppose 50. We know x bar 105 or 110, whatever. Then you decide whether this could be 110, 102, h1 will write, okay. So this is what we want to test. We want to test for mu. Then we set mu. You can write 105, 106, 1010, 109, whatever you want, and then you decide the alternative one. It's greater than 109, less than 109, not equal to 109, whatever you want, okay. You set the alternative one. Now we know mu here, we put mu here, we put x bar here, sigma here, n here. After putting everything, my question is, what is that you expect here? Suppose I get 28, then what should be your conclusion? When you are testing a hypothesis whether mu is equal to 109 or not, you get TS 28, then what should be your conclusion? 28 means far away, TS. This should follow standard normal, and if you go by the property, most of the observation they should be here. Now 28 is extreme case. You should accept or reject. Tell me. 28 is extreme. You should accept or reject.
Sir.
Reject. Why you need to reject? Because test statistic follows a normal distribution. And what is the range of normal distribution? It could be anything between minus infinity up to infinity. Then when you get a number 28, it's well within the interval minus infinity to infinity, because this follows standard normal. It could be any number, 280, 25, 2800, or minus number also, because this follows standard normal. Why you are rejecting a number 28? Thinking that it's extreme, it's big. There is a fear. Out of fear only we reject. That's why we are committing an error. We are committing an error because we reject out of fear. That's all, nothing more than that. There is no such thing called this is the rejection one, this is the acceptance one. What I want to say here is, sometimes we think extreme and we reject. Suppose COVID cases will be 1,000, okay, 1,000 in India. Then what will happen? We'll start traveling here and there, and all the activities will start. Then what will happen? Suppose we'll have fever, we'll reject the hypothesis that we got COVID. It's very, very highly unlikely that we are one of them. 1,000 in India. Can you imagine? It's very highly unlikely. So sometimes what we do is we reject a hypothesis. Hypothesis could be anything. Here mu is 109, thinking that it's very extreme. Even suppose you solve 100 problems, when you find test statistic in these cases, if you get some number like 1 point or 0 0.5, 0 0.7, 1.1, then you can go further and you can check. If you get a number like 28, 100, 200, you should reject. You need not go further. Any level of significance you take, because LS line normally comes here, right? We take 5%, 10%, LS line comes here, 1.96 or 1.64, we get 28 is far away. Okay, this is LS, this is TS, it's rejected. So you will be able to reject very easily because 28 seems very high here. I have not written 280, that is even very, very high. But why to reject? This should follow standard normal distribution. It should be able to accept all. So there is a chance of error, but we reject because the chance is very less. We reject it. So maybe I'm making a mistake. My hypothesis is wrong. So there is a chance of error. Rejecting a hypothesis when it's true. When it's true means what? I got coronavirus, okay, but that is the hypothesis, but I'm rejecting it. I'll give you another example. Suppose someone appears in an interview, okay. Now, I will ask 2 questions or 3 questions, whatever number of questions. I'm given 10 minutes time, and I have to either accept this guy or reject this guy. Suppose I asked only 3 questions. On the basis of 3 questions, I rejected this guy, okay. So, what is the error I might be committing in this case? I will base my decision on 3 questions, on sample. So I'm not rejecting on the basis of whatever knowledge he has. I don't have time. I have only 5 minutes time. I can't ask those 100,000s of questions I'm supposed to ask. I am asking only 3-4 questions. So I am basing on the sample. Even the problems you are doing in hypothesis test, there you are basing your result on a sample of 3 questions, 5 questions, 10 questions. You are basing on that. How I can ask? I can't ask him 100,000 questions. I have no time. I have no time to ask him 100,000 questions. So there is chance of error, because on the sample I have to decide. Because I have to decide on the basis of a sample, there is a chance of error. What is the chance of error? I will reject the candidate where I should not reject. So this is error. Reject the hypothesis. So I'm rejecting a candidate. Okay. When the hypothesis is true, when he is an ideal candidate. Okay. This is something, if I make, okay, I'm committing a mistake. That is called type 1 error. This is type 1 error. So what is type 1 error? I reject a hypothesis, okay, when it is true. When it is true, when I say the guy I'm interviewing, he is a very good one, but I'm rejecting because I have no idea. I don't have exactly idea. I have to base my idea on the 3 or 5 questions I will ask. On the basis of a sample only, we accept or reject a hypothesis. Even the test now, I mean, whatever papers they publish in US and all other places in the world, when it comes to the coronavirus pandemic, they accept or they reject, okay, basing on the sample. We have a AIM study on ivermectin. They use hypothesis test, they use confidence interval, okay. If you go through those papers, you will be able to know, similar to what problems you are doing now. What I am saying is there is a chance of error always, okay. This is the chance of error. Suppose I want to test whether someone is good at mathematics or not. What error I might commit before I say someone or I write an article in paper. I want to test that candidate, okay, from one of the schools in Bangalore. What might happen is I will ask some questions. On the basing on the questions, I might reject him. Ramanujan, I mean, he was unable to pass the board exam, but he is one of the greatest mathematicians in the world. Okay, so sometimes what happens is you are unable to judge someone. Okay, there is a chance of error. One of my students, he not only got through IIT, he got through MIT. He's a scientist now. Okay, but one of my colleague, he was working as a lecturer in chemistry, so he rejected many times his answers. there is chance that we commit error. This is a type of error, that is type 1 error. Okay, there is another type of error. What is that type of error? Type 2 error. Here we accept a candidate when he is not ideal candidate, he is not fit, but we can accept. Suppose I ask 4 or 5 questions, then what will happen? If I see the answers I expected, I'll be very happy, I'll accept him, but he's not a good candidate. The 100,000s of questions I'm supposed to ask, that is the population, I'm not asking. I'm asking only a simple number of questions. Even when you appear exam, what happens is, you are tested on the basis of 10-12 questions. On that basis, on that sample, they decide whether you are good at mathematics or not. When you say I got 80%, I think that you have 80% knowledge on that particular topic. Whatever you appeared in 12th, you studied mathematics. Normally we say in 12th math you got 80%. That means I think that you know 80% of the subject or books, whatever you studied or topics. But it might not be true, because the marks they've given on the basis of the sample, there is chance of error. Okay. So when we talk about the interviewing candidate, I will ask 3-4 questions and he's able to answer, I'm happy to accept him, but he's not a good candidate. So what I will do? That is an error. Probability of type 1 error, we say alpha. This is the notation. Probability of type 1 error. And beta is probability of type 2 error. And unfortunately, you can't decrease both error. We want to minimize alpha and beta. That's not possible. There is a compromisation. Okay, that's what I will show you. And this is called power of the test. I'm not introducing more symbols, but remember, whatever you predicted, okay, actually it's matching. Suppose you predicted something, okay, and you got actual, so there is no problem. Whatever you predicted, okay, suppose I can write AB to make things easier. Here AB, you predicted A, this is actually A, so this is fine. You predicted B, this is B, that is also fine, this is also fine. The problem areas are these are the problem areas. So if they are matching, then there is no problem. Okay, BB matching, there is no problem. A matching, there is no problem. The problem areas are these 2 types of error. I accept something which is not true. So now here, this is type 1 error. Okay, probability of type 1 error, that is alpha notation. If you come to this side, this will be beta, type 2 error, beta. Now combine, we have this. If they're overlapping, suppose here there is one mu, alternative is this one. Okay, so though the range for this is minus infinity up to infinity, but we want to accept only up to this. Okay, the blue we don't want to accept. For the other one, similarly we have beta this side, this is beta, okay, and this is alpha. This is type 1 error, this is type 2 error. Now this is LS, it will depend on LS. I'll show you the question here, though we'll do mathematically. Mu 20, mu 30 you are taking. Suppose I write mu 20 here, for 20 this is the graph, or mu 30, I'm checking between these two. If this is not true, then the alternative should be mu 30. Okay, suppose your test statistic comes here, then I will reject mu 20, I will accept mu 30, right? Suppose this comes here, if this comes here, test statistic, then what will happen? This comes to the green area, and this is not here. Okay, so this comes to the green area. That means if you compare this one, this is well within this, right? This one, so that means this test statistic is well within this curve. That means you want to accept mu 20. Okay, but from this side, if you see, you are committing an error. From this side it's fine, because blue area we are not supposed to accept. It came, the test statistic came to this side, so we are happy, okay, to accept this one. But from this side, if you see the other one, mu 30, okay, there might be a chance of error, that is beta. So you can't make both the things, you can minimize both the errors. Okay, so I'll show you one, this one, just see it. See, power of a test, I will show you. See the graph first, how when you are moving this, power you have to see, right? Power of a test I've written here. Okay. Now see, this is the blue one, the deep blue one is alpha here. Okay. And let me run it. See, alpha is decreasing. Okay. Then beta is increasing. You see, the red one is increasing. Suppose alpha is here. Okay, 0.033. Alpha is very small, the deep blue one. Okay, that is alpha. When alpha is very small, beta is this side. See, this red, this one, this red area. Okay, this area is increasing when the deep blue area is decreasing. So 1 minus beta is the power of the test. So what is 1 minus beta? Who can define what is beta? What is alpha?
Type 1 error.
Type 1 error. No, alpha is not type 1 error. You can say type 1 error, but probability of type 1 error is alpha. The notation, the area. Area means it's a number. Suppose 0.033. That's an area. That's a number. That is probability of type 1 error. You can say that is type 1 error, but actually that is probability of type 1 error. That is alpha. Type 1 error is the error. Similarly, type 2 error is a kind of error. The probability of that is beta. Okay. So now the question is, what is 1 minus beta? How can you define 1 minus beta, which is power of the test? Because power of the test is the probability of rejecting when it's false. That is power of the test. Remember, power of rejecting when it's true, that is alpha. Alpha is the probability that will reject something when it's true. That's not desirable. Something is true, we are rejecting. That's the problem. But what is beta? Beta is accepting when it's false. Then what is 1 minus beta? Rejecting when it's false. That's why it's called power. So I can define power of a test is the probability of rejecting H0, rejecting the hypothesis when it's false. That's good. Suppose some bad elements will come. Then what is power of the test? I rejected them and they are not our college student. Then that's good. That is the power of the test. I interview some candidates. I reject them. And finally somebody will verify and they know that they were rejected correctly. I mean, they were not good students. They inquire the college and they will subsequently they will know and they will praise me. They will call and they say, oh, you are able to identify properly. I will go to the market and I will bring mangoes. What will happen is I rejected all those bad ones. Then that is my power. Power of rejecting bad ones. Power of rejecting the false ones. Reject when it's false. That's good. But reject when it's true. Okay, I rejected mangoes, but they are good mangoes. That's the problem. Because seeing the skin and all, I have to decide. Maybe I will make a mistake. Those mangoes are good, but I rejected. I should not have rejected. So, what is power of a test? The power that I rejected all those mangoes which are not good. That's good for me. Okay, that's the power. Okay. So, power, if you see, power is 1 minus beta. So, 1 minus beta will increase if beta will decrease. So, let's run this and check. Now, power is increasing or decreasing? See, power is decreasing because your beta is increasing. Beta is the, the red, okay, light red sets, 2 sets are there that constitute your beta. So alpha is to the right hand side, 0.0082, that is alpha. Okay. Now in this, suppose you take this line, what we are changing here in this graph, we are changing what we are changing. We are changing the level of significance line, right? So when you say that when you keep a very small error margin for H0, alpha is very, very small, then power of the test also very small, 0.34. You want more power, means you have to give something for error, okay, alpha error. Beta is decreasing and then power is increasing, power 0.63. Power will be maximum 1, right? Power is 0.63. See, when you increase alpha, beta decreases, so 1 minus beta increases. Alpha is the deep blue. Now see, alpha increasing, power is increasing because when alpha is increasing, beta is decreasing. Now see, beta is alpha is 0.16 more, 25%, 26% alpha. Okay. Now see, alpha is very big, almost 40%. Almost 40% is alpha. Beta is very small. So power of the test is very high. So in this case, what will happen? You will be able to reject, if you make a very high alpha, you will be able to reject the false things. You have the more power of rejecting bad elements. I have more power of rejecting the bad mangoes. I have more power of rejecting bad mangoes. I have more power of rejecting bad mangoes because I have kept something, my margin very high. So power of the test is more. That means you are able to reject the wrong ones. You are able to reject the wrong ones properly. I mean at a very high level. Okay. That is the connection between alpha and beta and power of the test. Yeah. Now power of the test is 0.96. But will not try to make power of test very high. When you try to make power of test very high, then two things are good here. Beta is good, 1 minus beta is good. Beta is good means you are not accepting any candidate who are not fit. Okay, that's where beta is less. Your error of accepting candidates which are not good for the company is less. Also 1 minus beta is more because power of the test is connection with this type 2 error. Alternatively, you can say using 1 minus beta, they are one and the same. You are able to reject the candidates who are not fit for the company. They are one and the same. Okay, 1 minus beta terms you can say in terms of beta, but with a large alpha. Now we'll go and do the problem. Problem is very easy. You try to solve one problem, then once you solve one problem, you will be able to solve more problems. Okay, find the probabilities of type 1 error. So we'll find this probability. That is probability that I reject the hypothesis. Okay, reject H naught when it's true. Okay, that is this one you can do. Reject H naught. What is H naught here? H naught is mu 20 and H1 is mu 30. Okay, so reject H naught when I say I reject this one mu 20. Okay, what is the probability that I will do that? What is the probability that I will reject mu is 20? That means I accept mu 30 given that H naught is true. Sorry, on the basis of sample I have to accept or reject. Okay, what sample says, if the value is less than 28, H naught is accepted. Okay, I reject H naught means the value is suppose X is greater than 28. Okay, this is on the basis of sample because they are saying you see the sample, if it's less than 28 you accept it. I want to reject it on the basis of sample, so X must be greater than 28. That's why I'm rejecting. But H naught is true means mu is 20. So I have to find the probability that X is greater than 20. X follows whatever distribution I have to check in the question. X follows an exponential distribution with mu 1 upon lambda. Lambda is 1 upon mu. H not true, remember, true means mu 20. Mu 20 will take. Okay, so 1 upon 20. Because this is the link. Okay, with parameter lambda. Lambda is 1 upon mu. Mu is 20. Mu true. H not is true. So we have accepted this. Okay, in reality it's true, but from the sample it comes. Then you have to find the probability, whatever way you find 28 to infinity fx dx, you write this lambda e power minus x, or there is a formula directly you can use that one. Okay, 28 to infinity lambda e power minus lambda x, you can find this, or directly there is a formula, you integrate this one, or there is a formula also. Formula you can use probability x less than or equal to x, x greater than x, e power minus lambda x. That formula is there. If you want, you can use this one as well. So finally, if you see the answer, okay, whatever answer you get, that you write here. I don't know the answer. And the second one, if you want to do part 2 here, okay, I can do part 2 directly here. Mu is equal to 30. Okay, because I accept when it's not true, this H naught is not true. H naught is not true means mu 30. Okay, then you find x less than 28. So 0 to 28, I'll make it 0 to 28. 0 to 28, or I can use fx also, f28 I can find. Okay, or you can integrate with 30 and you will get one answer. Suppose this answer. These are the answers. Anything you would like to ask before I leave?
No, sir. Thank you.
Okay, fine. Thank you.